around us there are always some or the other kind of chemical reactions are happening. Like in previous classes we have already discussed about this. When the milk has kept outside at room temperature for overnight for a long time or more than that, so milk gets curdled. Why milk gets curdled? Why the milk is breaking into water and the fat substance? Because of the change in temperature, because of the curdling is the process, chemical reaction is taking place. Okay, similarly if we talk other reactions like grapes are ripening or over ripening or getting fermented, so fermented or over ripening of substance, chemical reaction is taking place there also. Cooking of food, digestion, respiration, all kind of activities are the chemical reaction one or the other ways. Okay, so there are few reactions are called physical change and few are called chemical change. Physical change, when the process is completely reversible, means at one point of time product can be reversed to reactant. And chemical reaction, chemical change is called when the process cannot be reversed, when product cannot be converted back to reactant. Okay, reaction goes only in one direction. Like cooking of a food is a chemical change. So once the food is cooked, that cooked food cannot be converted to raw food, correct? So like that only. But melting of ice and the molten ice, molten water is again we are keeping into refrigerator, again we can convert it into ice. So that is called physical change. Are you understanding the difference between physical change and chemical change? Now let's see one activity we have discussed. When magnesium is taken, magnesium ribbon is burned in a container, and in presence of oxygen, when magnesium ribbon burns, we get a totally new product. Okay, that is in the powder form, and that is white color powder form. Okay, so that is magnesium oxide. So reaction is happening between magnesium and oxygen, and magnesium oxide is forming. In that process, how we observe the chemical reaction has happened? By change in color, change in appearance, or change in temperature. Okay, so here the transformation into another chemical substance. So one substance like magnesium ribbon form, it was taken, color was different, appearance was different, and it has converted to magnesium oxide. Magnesium oxide is white powdery substance. So what is happening? The transformation of chemical substance into another chemical substance is known as chemical reaction. Like another example also, when hydrogen combines with oxygen, you are getting water. Okay, so hydrogen is gas, oxygen is also gas, but water is a liquid at room temperature. So you are getting transforming to totally new substance. Okay, so one or more, it is not necessary reactant should be always 2 or 3. Reactant can be 1, 2, 3 n number. Okay, product also can be 1, 2, 3 n number. What is reactant? The left hand side in a reaction, this is called reaction, because when we write in words the description, it will be very long. So short form of description can be written in a form of reaction. So this is called reaction, word reaction or word equation. So in this what we have written, the left hand side what are the components are written, they are combining with each other to giving transformation is happening in them and giving a new substance. So we will write an arrow between them. So these are left hand side are the reactant, right hand side is the product, and arrow indicates reactants are converting to product, like this. Okay, so let's see here. When a magnesium ribbon, we have done this experiment here, magnesium ribbon is burned, okay, and into oxygen and converted to magnesium oxide. Okay, this description of a chemical reaction, if we write in a sentence form, it's too long, it is taking one paragraph to write a description, but in with equation, in one equation we can complete it, this self-explanatory kind of reaction. Now you can see here what we did, magnesium plus oxygen gives, arrow we are writing, that indicates gives magnesium oxide. So this complete paragraph can come into one line, one equation. Okay, so equation, what is the advantage of writing equation? We can simplify the complete process in a small equation which can be self-explanatory, means it can be explained by itself by reading that words. Okay, and slowly as you go to higher classes you will understand the more symbols, more formulas, so you can also write reactions by yourself. That will be much more easier, because writing word reaction and skeletal reaction, then that that writing formulas in a reaction and the symbols in a reaction is much more easier for you. Okay, soon we will train you for that also. So let's see here, it can be written in a shorter form. So the simplest way to do this is to write it in the form of word equation. This is only called word equation. See here, magnesium plus oxygen gives magnesium oxide. In words we have written. If we know the symbol for magnesium, we can have Mg, oxygen symbol O2, magnesium oxide Mg and O2 when they combine MgO. How we can write? We can balance it also. We will teach you how to balance the number of reactant left hand side, the atoms, the number of atoms right hand side for the all entities should be same. Why it should be balanced? Why it should be same? Because according to law of conservation of mass, we have seen, accordingly the balance should be there. The mass can neither be created nor destroyed, but one form can be changed to another form. So we can see here, this side whatever number of reactants are taken, same number of atoms should be right hand side also. So number balancing only, that is called. So part by part we have to see one entity and we have to write a number accordingly, so we can get equation balanced. Okay, so let's see here further. Magnesium plus oxygen, what is this? Which is written on left hand side. This is right hand side. Arrow in between, there is arrow. Arrow indicates these components are combining to give these components. Okay, left hand side what we have written? We have burned magnesium ribbon in oxygen. So magnesium plus oxygen, they are called reactants. Okay, what are they called? Reactants. When they combine, you are getting a product. Here one product is there, magnesium oxide. In a white powder form, what we got, that is called a product, magnesium oxide. Okay, so the substance that undergoes chemical change in reaction, magnesium and oxygen, which are undergoing chemical change and forming a new product, that is called reactant. Okay, the new substance is magnesium oxide formed during the reaction as a product. So magnesium oxide is a product. What is the new substance we got? Magnesium oxide is a product. What are the reactants here? Magnesium and oxygen are the reactants. Okay, so all the three parts are there in the reaction. You can see a word equation shows change of reactant and product through an arrow. Arrow indicates these reactants are combining to give a product placed between them. Okay, so a complete reaction we can explain. What is the reaction? Magnesium plus oxygen gives magnesium oxide. Now the reactants are written on the left hand side, LHS, with a plus sign between them. If more than one reactant is there, we have to write plus sign. Why? Because we are go on adding that reactant to each other to form a new product. Product also can be 1 or 2. If it is 1, no need to write any sign. If there are more than 1, we have to write plus product side also. Okay, so similarly products are written right hand side with a plus sign between them. If there is, right now in this example there is only one product. If there is more than one product, then we have to write it. Okay, the plus sign between them. Like for example, another reaction if I write, we say sodium hydroxide combines with hydrochloric acid. What we get? We get sodium chloride and water. Okay, so let's see here. What are the reactants? Reactants which is written on the left hand side. This is symbol if we write NaOH plus HCl. There is an arrow in between which indicates these are the reactants converting to product. What are the products? NaCl plus H2O. Okay, are you getting? So this is the reaction. So here we can see left hand side there are two reactants, so plus sign between them. Right hand side there are two products, so plus sign between them. Similarly, the arrowhead points towards the product and shows the direction of the reaction. So reaction is going in which direction? Forward direction. Okay, this side when reaction goes is called forward direction. This side when reaction comes is called backward direction. We will discuss about that also later. Right now you understand forward direction. So is there any other shorter way for representing chemical equation? Yes, if we write in the form of symbols, we can represent the equation in a more shorter way. Like for example, magnesium plus oxygen, we are getting MgO. Okay, magnesium oxide. If we know the symbols, you can also write it very fast. Okay, then let's see. Chemical equations can be made more concise and useful if we use chemical formulas instead of words. Okay, so a chemical equation represents chemical reaction. If you know formulae of magnesium, oxygen and magnesium oxide in the above word equation, it can be written as magnesium plus oxygen gives magnesium oxide. Mg plus O2 gives 2MgO. Now if we see number of Mg, if we don't write this, just see how many Mg's are there. There is 1 Mg, here 1 Mg. Oxygen, there are 2 oxygen, but here there is only 1 oxygen. To balance this, what we will do? We can write it as multiplied by 2. This side we have to make 2 oxygen. So if we multiply it by 2, there will be oxygen is balanced. But at the same time Mg is only 1 this side and 2 this side. So what we will do? We will multiply Mg also by 2. So now we can see 2 Mg, 2 Mg. Then oxygen, here also 2 oxygen, 2 into O is 2 oxygen. Okay, so now it is balanced. This side also it is 2, here also it is 2, both are 2 here, like this. So this is called balance equation, like this. Okay, let's see now. Count and compare the number of atoms of each element on left hand side and right hand side. We compared just now. There is 1 atom of magnesium, 1 atom of magnesium, 1 atom of 2 atoms of oxygen, 1 atom of oxygen, left hand side to right hand side. So what we should do? We should first, to balance the oxygen, we should multiply by 2. Now oxygen is balanced, here 2 and here also 2. But in this process, because magnesium and oxygen are bonded together, so there are 2 magnesium, here only 1 magnesium, so make it multiply by 2. Now this equation is a balanced chemical equation. Okay, let's see next. If yes, then the equation is balanced. Okay, in that equation it was not. We have added the number. By number balancing we have done, multiplied by a suitable number to get the equation balanced. Okay, why equation has to be balanced? According to law of conservation of mass, matter can neither be created nor destroyed, but one form of matter can change to another form. That is why we have to balance the equation. Okay, so we will write the answer for this. If not, then the equation is balanced. Okay, and this equation is not balanced. So what we will do? If not, then the equation is unbalanced, because mass is not the same on both the side of equation. So our given equation was not balanced. We have balanced the equation by multiplying by 2 to left hand side as well as right hand side also, to Mg and MgO. Okay, equation is a skeletal chemical equation for burning of magnesium in air. Burning of magnesium in air. So this equation is explaining. What is it explaining? We have taken magnesium ribbon, burn in presence of oxygen. It converts into, the ribbon converts into a white color powder, magnesium oxide. So that complete story we can write just in a form of one equation. If we balance it, the number of atoms both the side, if it is equal, then it will be satisfying law of conservation of mass also. Okay, so keep watching. We will be doing few more equation balancing and we will teach you new methods of balancing. chemical reactions and equations. What do you mean by chemical reactions? Every activity in our daily life is associated with some or the other kind of chemical reaction, okay, like it is. And if we write in the form of equations, we can say reactants are left hand side and the product on right hand side, okay. So what are the chemical reactions? Like cooking of food is a chemical reaction. Chemical reactions can be physical reaction, physical change and a chemical change. Also we can divide into that. Physical change means the processes which are reversible, like melting of ice. That molten ice, if you put it back into the refrigerator, you can convert it into ice cubes. So that is called physical change. Any time, any point of time you can reverse the activity. Chemical change means once it undergoes a particular chemical reaction, the product will obtain. That product cannot be reversed back. The process cannot be reversed back to the previous state. Like cooking of food. So cooked food and the raw food, appearance, color is totally different, and you cannot make it back to the cooked food to the raw food, or digested food to the undigested food, like that. So these are called chemical changes. Chemical changes are the changes, certain changes which cannot be reversed, okay. So let's see now. There are few things are there. What happens when milk is left at room temperature during summer? What happens? Milk, because of the higher temperature, milk will start breaking it. That is called, it will start converting into a curdle form, and the small fragments will start separating, water will start separating, fat body will start separating. That is called curdling of milk, okay. Then an iron tawa is left exposed to humid atmosphere. So iron, all of you know, iron is having a very good tensile strength. It is one of the strongest element, okay. But at the same time, the small disadvantage with this element is whenever it comes in a contact with any kind of moisture or any kind of moist vapors, or what we can say, any kind of moisture in the environment, means it starts undergoing, converting to a brownish color, reddish brown color, rust. That is called corrosion, okay. That process is called corrosion. Rusting is an example of corrosion. Corrosion means degrading of the substance. So substance will start breaking into flakes, and like that the iron gets weaker by this kind of corrosion kind of activity. So this is also one of the chemical reaction taking place here. Grapes gets fermented. So the fermentation process, when the grapes are having carbohydrate present, sugar content present in it, it is sour to taste, so some acidic substances also present. In presence of atmospheric conditions like temperature and surroundings, oxygen, it undergoes fermentation. So it goes ripening, and the over ripening will start happening. So fermentation can be having two types, advantages as well as disadvantages. This is a chemical reaction. So advantages, it can be used by a wine industry to convert into wine, or disadvantages, the fruit gets over ripened and it gets spoiled, so it is no use for eating. Anything is possible. Then food is cooked. This is also a chemical change. The cooked food cannot be converted back to the raw food, okay. Food gets digested in our body. This is also one of the chemical reaction. Digestion process is always associated with combustion, which we inhale the oxygen in a respiration process. When we inhale the oxygen, that oxygen helps in breaking the food into the body, okay. Plus there are some enzymes and some acids are also getting secreted into the body lining inside, like stomach lining, intestine lining, that is helping breaking food into further smaller and gets absorbed into different parts of body, okay. And like that it gives energy by burning. So when we respire, that is also a combustion process takes place. Combustion means any burning of any substance in presence of oxygen is called combustion, okay. So what is happening when substance burns? Burns means it's not about catching fire every time. Breaking of a substance and liberation of energy, that is also called burning of a substance. So combustion means burning of a substance in presence of oxygen to liberate large amount of energy, okay. So let's see the next one. The nature and identity of the initial substance has somewhat changed, okay. We had observed it in this complete process. The complete process appearance is totally changed. Like milk was looking white color, smooth homogeneous mixture, and then when it curdle, it will be looking like a flaky substance. Iron will have before coming in contact with moisture it is a strong metal, but when it comes in contact with any kind of moisture it undergoes corrosion, so reddish brown color corrosion, so appearance will change. Okay, this is only showing chemical reaction has taken place. Okay, now what is meant by chemical reaction? Chemical reaction means any two or more substances come in a contact with each other to give a new product, or we can say reactants. How the reaction is written? Reactants are written at the left hand side, products are written at the right hand side. Between them there is arrow indicating reactants are converting to product. Okay, it can be more one reactant also, it can be two reactants, it can be three reactants. At the same time it can be one product, it can be two product, or it can be three different products also, depends on what kind of reaction is taking place. Okay, so when chemical simple combinations are taking place, two chemicals are combining at a time, we can have only one product, or we can have two or more, one major product and side products also possible, depends. These are all called chemical reaction. How do we know that chemical reactions are taking place? We will understand by observation. By our observation we will observe there is a change in color, like for example rusting of iron. We had seen iron color was the dark brownish color, and then when it is rusted the color has changed, the appearance was very crystalline, flaky, appearance has changed. As well as in some of the processes you will see the temperature is increased. When you hold a glass, and in that glass when you are mixing it, suppose salt and water if you are mixing it, or you are having some of the substances, so you will observe the glass has, the temperature of the glass is changed. So any chemical reaction when it is happening, there will be either heat liberated or heat absorbed, so appearance will change, color will change, all this will indicate there is a chemical reaction happening. We can observe it and identify. So let us have an experiment, a small experiment, that is called activity here. So clean a magnesium ribbon. One magnesium ribbon will be taken about 3 to 4 centimeter long by rubbing it with sandpaper. The sandpaper, by rubbing it will be made smooth. Then hold it with a pair of tongs. Tongs is the instrument which is used in the laboratory to hold any kind of hot object, or if you are using playing with the heat, so we can use that tongue for holding it. Okay, burn it with using a spirit lamp or Bunsen burner and collect the ash. What will happen when it burns? It will convert into ash, so formed in a watch glass. In a watch glass is a glass plate, small glass plate is called watch glass. In that ash will be collected, and then it will be observed how it was looking magnesium ribbon before, how it is looking after burning. Okay, burn the ribbon and keeping it away as far as possible from your eyes. Why? Because that small kind of ignitions will come that may harm our eyes, so that's what. So what do you observe? What do we observe? We will observe it, the magnesium ribbon color was different and the ash color is different. It means there is a chemical reaction happening there. Okay, so let's see that how it is happening. See, this is a Bunsen burner. It is invented by a scientist named Bunsen. That's what it is called, Bunsen burner. There is a small magnesium ribbon. This is called tong. It is a holding device, and when magnesium ribbon is burnt in presence of burner, what will happen? The ash is being collected in a container. The color of the ash and the color of the magnesium ribbon is different. What is it indicated? Mg burns in presence of oxygen, so you are getting MgO, magnesium oxide. How we can see here? See, magnesium ribbon burns with dazzling white flame and change into a white color powder. Okay, then this powder is magnesium oxide. This white color powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present. So let's write a reaction. How we will write? What are the reactants? Our reactants are magnesium and oxygen. When magnesium and oxygen combines, you get a white color powder, that is magnesium oxide. What is the appearance? White color powder. Okay, we can write it in the form of symbols also. If you are familiar with this symbol, magnesium symbol is Mg. So Mg plus O2 gives MgO. O2 is oxygen, MgO is magnesium oxide, okay, which is white color powder here. So this is the experiment. What did we observe in this experiment? We observed it, the change in color, change in appearance, change in, see, color and appearance also, color is change as well as appearance. Here it is a kind of strip, ribbon kind, here it is powder form, okay, as well as change in temperature. There are many activities. These are all called reactions, chemical reactions. So another activity is there. Here next experiment is there. You can observe it here. This is called test tube. Test tube is used in a test tube stand. It is kept, and it is used always for doing a small quantity of chemicals. Reactions can be done in the lab and can be observed. So we can see, take lead nitrate solution in a test tube. In a test tube, lead nitrate solution is taken. Okay, suppose this is a lead nitrate solution. In that, potassium iodide solution is added. Suppose this solution is potassium iodide, which is added to this lead nitrate solution. What we will observe? What we will observe? We will have a reaction. We can write a reaction. Let's write a reaction. Lead nitrate plus potassium iodide. What we get? Lead nitrate plus potassium iodide. This kind of reactions are called double displacement reaction. We will study the type of reactions also. Just for your reference, your curiosity, I am telling this. This is double displacement. Double displacement means shifting of any of the component from one place to another. Double means at a time two components will displace. We can see here in lead nitrate, lead is one component, nitrate is another. In potassium iodide, potassium symbol K is one component, iodine I is another component. Now what will happen? Interchange will happen. See, one displacement is when Pb has gone and combined with I2. So you get one PbI2. Second displacement is when potassium combines with nitrate. So you are getting KNO3, potassium nitrate, like that. So twice we have a combination and two times bonds are breaking and the new bonds are forming. This kind of reactions are called double displacement reaction. So what we observed here? We observed it when lead nitrate combines with potassium nitrate in a test tube. We are getting the precipitate of lead iodide. Okay, we are showing the indicating the arrow downwards. Always you remember this, in a reaction we are using this kind of symbols and you should understand it. Whenever arrow upward is written means the gas is liberated. Okay, any gas is liberated because gaseous substances will try to go up because of the very less interparticle force of attraction and the light mass. Okay, so gas is liberated whenever we are writing arrow upwards. Whenever we are writing arrow downwards, it means precipitate. PPT means, here we are not talking PowerPoint presentation. PPT means precipitate. The short form for precipitate in chemistry is PPT. So we are showing arrow downwards. It means there is a precipitate. Why? Because when the experiments happens in a test tube, we will observe it at the bottom of the test tube. There will be some solid will separate out, and that is why the arrow downwards it is shown. Liquid state, there is no arrow or any indication, because when no arrow is indicated means substance is in, might be in the liquid state. Okay, so this liquid state or solid state also, this can be indicated gas liberates and this indicated PPT appears. Okay, so we have to remember all this.